Hi, folks. Welcome back to 7.5, part 4. And in this one, we're going to take a look at the quadratic equation. All right. Now, this is really important here. We're going to go ahead and start by sort of highlighting the similarities between these three equations that we see here. All right. So in 7a, we have just the x is squared. In 7b, we have the 5x is squared. And in 7c, we're introducing this sort of notation where this is really 2 times sine x squared equals negative sine x, okay? So we're actually taking the sine x and squaring that, just like we did the x and the 5x in the previous question, okay? All right, so let's begin with 7a, all right? What I'm about to say is really, really, really important, okay? Do not divide both sides by x. If you divide both sides by x, I'm going to know you haven't watched the video, okay? Do not divide both sides by x. Instead, here's what we're going to do. For all quadratics, our idea should be move everything to one side, set it equal to 0. So 2x squared plus x equals 0. Okay. If this is your first step, I know you watched the video. Good job. All right. Now from here, we're going to factor. It looks like we can pull out an x from both terms. We're left with 2x plus 1 equals 0. And by the zero product property, I can say that x equals 0 and 2x plus 1 equals 0. This is already solved, and that's fine. But the second one, I need to subtract 1 and divide by 2. So 2x equals negative 1, x equals negative 1/2. All right. So before we move on to 7b, I really want to point out that we have a quadratic. That means we have 2 solutions. Okay, sometimes these numbers are the same, but they still come up twice. But you have to make sure with a quadratic that you get 2 solutions, whether they're real or imaginary, doesn't matter. You should have 2. Okay, if you're left with 1, it means you did the thing I don't want you to do, which is divide by x. Don't do that. All right, we're going to follow the same procedure for 7b. Okay, so we are going to move everything to one side, set it equal to 0. And we're going to factor. This time, we're factoring out a 5x. And I'm left with 2 times 5x plus 1 equals 0. Now, by the zero product property, just like I did before, I can set 5x equal to 0, and I can set this equal to 0. Okay? So I'm going to say 5x equals 0. And let's go ahead and do 2 times 5x is really 10x plus 1 equals 0. In the first one I have here, the 5x equals 0, I'm going to go ahead and divide both sides by 5. Here's one solution. And in the second one, I'm going to subtract 1 and divide by 10. Quadratic means I have 2 solutions. Okay, so we see that square and we're thinking we better have 2 solutions. Now we're going to use the same framework to take a look at 7c. All right, so I'm going to go ahead and do the specific solutions first, because I have just x. I don't have like 2x like the last video or 7x, just have x. So we're going to do the solutions over the one time around the unit circle first. So 2 sine squared x plus sine x equals 0. I'm going to factor out the sine. Sine x 2 sine x plus 1. Now I can use the zero product property. Sine x equals 0 and 2 sine x plus 1 equals 0. All right. Now, we do have to do a little bit more work because this is a trig equation here. So we have to solve for x. Like getting sine x by itself is not enough, right? So where are the angles where we have a y value of 0? And it turns out that that's 0 and pi. All right, so 0 and pi are the two solutions that come from here. All right, now over on the right, I actually have to solve for sine x first. So I get 2 sine x equals -1, or sine x equals -1/2. And when I solve this, I get x equals, let's think about this, 7 pi over 6 and 11 pi over 6. All right, so quadratic structure means we had two trig equations that we had to solve. And each of those gave us some solution. So we actually have 4 angles that make this equation true. Okay. Now, I'm going to go back to something we were doing in the first few videos where we were talking about solutions and how to write them. Is it 2 pi k? All right, and I'm going to draw these on here so we can see. So we've got 0 and pi. Right, so those come from these two, right? 0 and pi. Now these two, instead of writing it as 0 plus 2 pi k and pi plus 2 pi k, I can actually write this as x equals 0 plus pi k, right? Or I can just say x equals pi k, where k is an integer. All right, please don't write them separately. Please condense them when you can. So here's one general solution. Now the next one, the 7 pi over 6 and the 11 pi over 6, those are 7 pi over 6 and 11 pi over 6. Those are not exactly halfway around the unit circle from each other. So we do have to write those separately. X equals 7 pi over 6 plus 2 pi k, where k is an integer, and x equals 11 pi over 6 plus 2 pi k, where k is an integer. All right, so even though we had 4 over here, we were able to condense 2 into 1, and then the others, we just had to write them the way they were. Okay. All right, so let's take a look at question 8 now. All right, and so I think we're getting a little bit better at this, and we can kind of see that some of the similarities between things. And so in particular, I notice in 8a that I have 2x squared minus 3x plus 1. But if I scoot down to 8c, I see that I have a 2 sine x squared minus 3 sine x plus 1, right? So 8a and 8c are actually super, super similar. 8b is in there because I want us to practice, factoring a little bit because I think it's important. Okay, so let's factor. I'm going to think about how to group things. All right, so a times c, 2 times 1 is 2, and then the b value goes on the bottom. All right, I think about numbers that multiply to make 2, but add to make -3. So -2 and -1 will do it. So I get 2x squared minus 2x minus 1x plus 1 equals 0. I factor the first two. I pull out a 2x. I'm left with x minus 1 minus, pull out a -1, x minus 1. All right, this factors into 2x minus 1 times x minus 1 equals 0. And I will let you do the arithmetic, but we should end up with x equals 1/2 and x equals 1. Okay, So moving through that kind of quickly, but we are factoring here. It should be something that we're feeling pretty familiar with. All right. Okay, let's go ahead and do 8b. Now, in order to do 8b, before we do anything else, we actually need to subtract the 5 to the other side. So 9x squared plus 12x minus 5 equals 0. Now, a times c is negative 45, b is 12. So I'm thinking about numbers that multiply to make 45, but add to make 12. Let's see. What do we have? Well, if the numbers get kind of big, then what I like to do is sort of write out a list of factors. So I know 1 times 45, 2 times, nope, 2 doesn't go into there, 3 times 15, 5 times 9. Now I bet most of us were thinking 5 times 9 and thinking, though, you can't possibly get 12. But if we write them out in order, I think we come up with this 3 times 15, which maybe doesn't pop up into our brains automatically. And if we have negative 3 and a positive 15, we'll multiply to make negative 45, but add to make 12. Awesome. All right, so I've got 9x squared minus 3x plus 15x minus 5 equals 0. I can factor out a 3x minus 1 plus 5, 3x minus 1. All right, 3x plus 5 times 3x minus 1 equals 0. And by the zero product property, I can get x equals negative 5/3 and x equals 1/3. Okay. So a little bit of factoring practice, right? Always important, good skill to have, but now let's apply it to a trig equation. All right, so I'm going to cheat a little bit, and I'm going to pretend like we did all of this, all right? And we're really going to get sine x equals 1/2 and sine x equals 1, okay? Because, and let me actually leave a little bit more here before we jump right there. We can really think about this as 2 u squared minus 3u plus 1 equals 0 if u equals sine x. Okay, so it's almost like we're tricking ourselves and saying, let's go back and do some of this stuff with a u. And at the end, we'll go ahead and plug in that sign again so that we get what we want. All right. And this is oftentimes a really important mathematical trick, if you will, where we sort of think about things that we know, factoring, and how we can use them in a new context. All right, so now if sine x equals 1/2, I know that x has to be pi over 6 and 5 pi over 6. And if sine x equals 1, I know that x equals pi over 2. Okay. Now, general solution time. Let's go back up, and I'm going to grab this unit circle and bring it back down here. And let's go ahead and draw our solutions. So I've got pi over 6 and 5 pi over 6. Well, those are not halfway around the unit circle from each other, so I am going to have to write them as separate solutions. And then I also have this pi over 2, which I'm going to have to write with a separate plus 2 pi k. All right, so no shortcuts here. X equals pi over 6 plus 2 pi k. X equals pi over 2 plus 2 pi k, and x equals 5 pi over 6 plus 2 pi k, and for all of these, k is an integer. All right, so that's it for our quadratic ones. Come on back in our next video where we're going to take a look at applying different trig identities to help us solve equations.